Welcome to this video, where we will clearly explain the Pauli-X and Pauli-Z quantum gates. We need quantum gates because quantum computers use qubits that can be 0, 1, or in superposition. These gates control and manipulate qubits, much like logic gates control bits. Classical gates, like AND or NOT, are irreversible, operate on bits, and are deterministic. Quantum gates, such as Pauli-X and Pauli-Z, are reversible, operate on qubits, and are probabilistic. Remember, all quantum gates are reversible. A quantum gate is a mathematical operation represented by a matrix that acts on a qubit state. In circuits, qubits are horizontal lines, and gates are boxes that rotate or flip qubits in quantum state space. The Pauli-X gate, also known as the quantum NOT gate, is a bit flip. It flips the qubit from 0 to 1 or from 1 to 0, similar to a classical NOT gate. The Pauli-X gate is represented by a matrix, and its circuit symbol is a box with an X. It can be seen as flipping a light switch on to off or off to on. The Pauli-Z gate is a phase flip. It does not change 0 or 1, but changes the sign or phase of the one state. This phase change is crucial in quantum interference, though invisible in classical computing. The Pauli-Z gate is represented by a specific matrix. Intuitively, it flips the direction of the wave, not the value. Phase matters when qubits interfere with each other.